Hi everyone, I hope that you guys are okay. So the tutorial we'll be doing today covers work from the 2nd of September to the 13th of September. And I will be doing activity 1 to activity 3 with you guys. So the first activity basically asks us to show how an equal allocation of resources amongst individuals is not necessarily efficient. And then they have requirements for how you should draw it and what axis should be labeled as what. So here is the proper diagram that you're supposed to draw, right? And I'm just going to have my own little rough draft that I drew on paint just to help you guys understand if it's like, making if it's all getting confusing over there. So this is what mine looks like. So I've decided to split the graph into like color sections. So the gray will represent Lindy's portion of the edge width box, and then the maroon section will represent Chris's portion of the edge width box diagram. And so what you can see over here is that you have your necessities for Chris on this axis and your luxuries for Chris on this axis over here. And then for Lindy, your necessities are this axis here, and then the luxuries are this axis over here, right? And then now let's just look at Chris for a second. The total utility curves of Chris, not total utilities, the indifference curve for Chris are these ones over here. And as you know, with your indifference curves, the higher your indifference curve is and the further away from the origin it is, then the higher total utility you will receive. So for Chris, he'd get the highest total utility from the combinations of necessities and luxuries here. So let's just say that was 100 necessities and whatever, and this was like 20 luxuries. So every point along here where you have higher necessity and luxury combinations would yield a higher total utility for Chris. And then now looking at Lindy, for Lindy, the total utility curves now go this way. And this means that this total utility curve over here will be the highest utility for Lindy, and this will be the lowest. So on this diagram, the highest total utility for Lindy is the lowest for Chris. So if Lindy were to now just, haphazardly just decide that she was going to consume this combination of necessities and luxuries, then the allocation of resources would leave Chris with the lowest utility possible for him. So then now to answer the question. So let's just say we take this diagram and we split it in half, right? So that would be your half point. I can't draw it on right now. But let's just imagine that we're dissecting this thing into halves. This would be a point A, or as they drew it in the diagram over here. Your point A would be over here, but for us the point A is somewhere over here, right? Point A is where the necessities are equally distributed. We are halfway through Chris. So 1, 2, we are halfway through his total utilities. For Lindy, we are halfway through her total utilities. There we have equal allocation of resources. But this is not on anyone's total utility indifference curves. It's not even on the contract curve. The contract curve I will explain now. So in order for them to be efficient, then they would have to move to some point on the total utility curves, on each of their own indifference curves. And then for them to have like optimal efficiency, that would be at any point on the contract curve. Now the contract curve is the curve that is drawn through the points of tangency of each individual's total utility. So indifference curves I meant. If you hear me calling a total utility curve, then you know I'm talking about the indifference curve. So as I was saying, the contract curve is now going to be drawn through the points of tangencies. So at every single point at which Lindy's total utility curve, the gray, is touching the total utility curve of Chris, you have tangency. And the contract curve will be the line that is drawn through these tangency points. And this represents the optimal and most efficient distribution and allocation of resources. So I hope that's clear for everyone. So at point A, yes, there's an equal distribution of resources, but no one's indifference curve is even there. Like there's no one's indifference curve where my pointer is right now. So no one's getting the utility they should be. And then if we move to point on the total utility curve where you have tangency, then that means that the marginal rate of technical substitution of Chris and the marginal rate of technical substitution of Lindy is equal at each of the points on the contract curve, like these points. And that is the most efficient allocation of resources. And what is important to note about this contract curve is that all these points of tangencies on the contract curve represent allocational efficiency, because at this point the marginal rate of substitution for Chris is equal to the marginal rate of substitution for Lindy. Okay, so now activity 2 is a true or false or correct or incorrect type question. And now we're still looking at the Edgeworth box diagram. And so I've just tried to like squeeze it into the side here. And you need to basically answer whether the question is like true or false based on what the statement says. And so the first question says, a distribution of the two sets of products between the two sets of consumer is efficient if the indifference curves are tangent. So this question is saying that the allocation of two resources between two consumers will be efficient if you have tangency on the indifference curves of each consumer. So this is correct. Back to what I said in the previous activity is that at the point of tangency, you have efficient allocation of resources between the two people that are in the scenario. And then Pareto optimality refers to a situation where products are allocated in such a way that some consumer can be made off without making some Pareto optimality refers to a situation where the products are allocated in such a way that some consumer can be made better off without making someone else worse off. And now to explain this, the statement is saying that Pareto optimality basically means that you can't make someone better off, like without making the other person suffer. So let's just say this was Pareto optimality. Then you wouldn't be able to move elsewhere without making you wouldn't be able to move higher up onto another indifference curve for Chris without making Lindy worse off. So remember when I said the highest point on the highest total utility for Lindy is the worst for Chris. So Pareto optimality basically means that if you're at that optimal position, then you can't move without making the other person worse off. So if you're going to move from this point over here to this point over here, then yes, Chris would be better off, but Lindy would be worse off. Therefore, you don't have Pareto optimality. So in this case, I would personally disagree with the memo and say that this is incorrect because they say can be and it's supposed to be cannot be. And then the next thing says by moving from an inefficient distribution point in the Edgeworth box, by moving from an inefficient distribution point in the Edgeworth box diagram, at least one of the consumers will experience a higher total utility, while the other consumer will still experience the same level of total utility. So basically, they're asking, by moving from, remember that point A that we had identified, one person will be better off and the other person will receive the same total utility. And because at this floating point here, no one was even good. By moving here, then they both will be better off by moving to a point on the contract curve. So that's why this one is also incorrect. And then distribution points on the contract curve are also synonymous with Pareto optimality. So at every single point on this curve here, remember I said you have the most efficient and optimal allocation of resources, and that's why it's all the same. Like Pareto optimality means that you have the best allocation, and you can't move from that point without making someone else worse off. And at every single point here on this contract curve, you have the best allocation of resources, and if you move from the allocation of resources on this contract curve, then someone will be worse off. Hence, the points on the contract curve are Pareto optimal or Pareto efficient. I hope that makes sense. So, the contract curve represents the best allocation of resources. You can't move from this point. You can't just put yourself over here without making someone worse off. So every single point on this curve, wherever you move, we will all be good. And that is basically the concept of Pareto optimality. So hence, it's synonymous. Okay. Now moving on to activity 3. So then activity 3 is basically saying, it's basically asking you to give the efficiency criterion for when you are allocating resources to the production of two products in one specific firm. So that's the first scenario. And then the second one is the allocation of production factors amongst different firms. And then the third one is the combination of output between each firm. And so basically the trick here is to be able to see that now we are talking about allocation of resources between production of two outputs in one firm. So you allocating labor and capital to producing apples and shoelaces in firm B. And then the second scenario, you are saying how will we allocate labor and capital between HP and Mac, on Apple I meant. Then the third one is how much of shoes and apples must each firm produce. So then for the first scenario, which is how should you allocate available resources to produce two outputs, then the marginal rate of technical substitution should be equal for each of the products. And then the second one is that the marginal product of labor in firm 1 should be equals to the marginal product of labor in firm 2. So this is when you're allocating the labor and capital between two firms, then the marginal product of labor in firm 1 should be equal to the marginal product of labor in firm 2, and then the marginal product of capital should be equal to the marginal product of capital in firm 1 and firm 2. And then lastly is how do we choose the correct combination of outputs for each firm? The marginal rate of product transformation in firm 1 should be equal to the marginal rate of product transformation in firm 2. So basically the key here is just to be able to identify what we're dealing with. Are we dealing with allocating to production or to the production of two products? Are we dealing with allocating to production between two firms, or are we dealing with production of two products, like the quantity that should be produced? I hope that makes sense. Also, because you guys are writing on this week, basically. Yes. Wait, is it? Yeah, you guys are writing soon, and please just make sure that you guys are reading carefully to see that you understand, because with the last test you guys weren't picking up on tricks and things like that. So make sure that you read in this upcoming test whenever you see a question like this one and a question like the one before with that correct or incorrect statement thing. Okay, cool. So in case this assessment, this video will be listened to another date. The you guys are writing soon that I'm referring to is the test on the 11th of September. Okay, so I hope you guys understood the work. If you don't, feel free to consult with your tutors, and part 2 will be coming for the rest of the tutorial. So for activity 4, 5, and 6 and 7, and so on, all the different parts will basically be uploaded. So you will be getting the rest of the video or the tutorial in due time.